So this is the top of page 3 of your packet, which should be the other thing that's out. Okay, so now that we've explored some basic graphical behavior of rational functions, okay, we're going to get into and we're going to develop certain things. Okay, so far we've found domains, we found ranges, we found vertical asymptotes, and then Thursday of last week, we started finding horizontal asymptotes. Okay? And then we were going to do more of that on Friday. We were going to finish it up today, and then tomorrow is ACT, Wednesday is ACT keys, and so that Thursday we're going to pick up on some more stuff. Okay? So we're going to streamline that now with the 7 steps that you need to be successful in this chapter. Okay? So, you like that? I learned how to do that. I can change the color.
What?
Aha!
Do the teal, I like teal.
That one?
Sure.
Close enough. Okay? So, first off, you are going to simplify the rational function and then find the domain. Write that down as is. This goes on your sheet. First line, step 0, you need to simplify your function, okay, and find the domain. Now, by saying simplify the function, that means that you might have to factor the top and or the bottom. So you might have to do some factoring on the top. You might have to do some factoring on the bottom. Okay? You might have to do that. Okay? Finding the domain, then, you are really finding the restrictions and where are the restrictions in the domain? How do we find those? Denominator is where the denominator equals 0. You were searching.
I didn't want to get it wrong.
I understand. Sometimes you got to take a leap off the cliff. You know what I mean? Because sometimes it's a nice, fun old waterfall or something that you're, landing in. Okay. All right. So first step, or really the 0 step. The reason we do it the 0 step is because we need to do it before we can even start. We gotta factor that. We'll get more into that later on this week, where it'll definitely help you to factor first. Okay. But that's why we call it the 0 step. Okay. Then our first step is we are going to find any and all vertical asymptotes. Okay? Remember that vertical asymptotes are of the form x equals some number and x equals some number and x equals some number and as many as we have, okay? But they're all of the form x equals some number. Okay? And where do we find them from? What about the domain? They're the restrictions, yep. Okay? They're the restrictions from our domain. So we just take off the not equal to. In the domain, it's x cannot equal. We take off that not equal to. That's our vertical asymptotes. Okay? All right? Now, this next one, this next step 2, is what we were supposed to do on Friday, but it snowed. Okay? Yeah, Boo is right, because we should have gone to school.
Yes,
no offense. We should have gone to school, because it only snowed like 4 inches. Okay?
Yeah, we know.
Okay? I'm not complaining. I'm just saying we should have went to school. Okay?
Snow, not school being canceled.
Oh, I was booing about school being
I would have
canceled.
rather had school.
Because I would rather have gone to school on February 24th than June whatever. You know what I mean? Okay? So, finding the horizontal asymptotes. What we have to do here is you are going to need to compare the degrees. Okay? Now, let's take a pause for the cause. What's the degree of a polynomial function? We talked about it a couple of months ago. We came back to it a couple of times since then. How do I figure out the degree of a polynomial function?
In the exponent.
What about the exponent?
It's the number, so it's like
It's the
I don't know how to explain it, but I know it's
degree. It's got something to do with exponents. Bless you. Not first.
the whole one.
Nope. It's only one of them. Say it louder. It's the biggest exponent. Okay? It's the biggest exponent. So we're going to compare the degree of the numerator to the degree of the denominator. Now, so far, your numerators have just been numbers. Okay? They've been constants. Okay? And so what we're going to do now is we're going to move off of the constants, and that numerator is going to be its own polynomial. Okay? So I've got three choices here for when I compare two numbers, because I'm comparing a number on the top to a number on the bottom. Okay? So my first choice is that the top is bigger than the bottom. Right? I could have 4x squared over 3x plus 2. Okay? The numerator has a degree of 2. The denominator has a degree of 1. So I have a top bigger than the bottom case. If that's the case, then my horizontal asymptote is... I thought I could get through it, but I should have stopped. My horizontal asymptote is none. There is no horizontal asymptote in that case. With me? Okay. What's another way that I can compare two numbers? Top and bottom. What's another way that I can compare top and bottom? Top can be bigger. Not yet. Bottom can be bigger. If the bottom is bigger, and this is the case that you've been doing up to this point, your numerator degree has up to this point been 0. Your denominator degree has been 1, 2, 3, 4, whatever it's been. Okay? So what's the horizontal asymptote been so far for us? No. Y equals 0 so far has been the horizontal asymptote. So if the bottom degree is bigger than the top, so like 4x over 3x squared plus 2, the bottom degree is bigger than the top, then our horizontal asymptote is y equals 0. Okay? What's the third way that I can compare two numbers? Top is bigger, bottom is bigger, they're equal. Yep, top equals bottom. then if that's the case, oops, I forgot horizontal asymptote first. And if that's the case, then my horizontal asymptote is y equals a over b. And I get a and b from the coefficients of the degree term. So for instance, what I mean by that is if you look on the next, or on in the green packet at the top there, okay, we've got f of x equals 2x minus 4 over x plus 2. Both the numerator and the denominator have degrees of 1. Correct? So top equals the bottom. So then I look at the coefficients, which are 2 and 1. So my horizontal asymptote here would be y equals 2 over 1, or simply just y equals 2. Okay. If this, on the sideboard here, if I've got 4x over 3x plus 2, now both have a degree of 1. And so my horizontal asymptote would be y equals 4/3, because they're the coefficients of the degreed term. With me?
That's just if there's just x and x, right?
Or if it was x squared and x squared.
That's what I mean.
Yep, if this were the case, if it was 4x squared over 3x squared plus 2, same thing. Yep. Okay. As long as the degree of the top is equal to the degree of the bottom, you take the coefficients of those terms. Okay? I'm going to scroll back down. With me on that. Okay? That's what we were going to develop on Friday. So we just did all of Friday's class in the last 3 minutes. Okay? You were just going to develop it. We'll go purple now for a while. Okay? Then, our next step is we are going to find the y-intercept, if there is one. How do I find a y-intercept? For x. Okay? So I set x equal to 0, and I solve it, right? Okay? All right? Then my answer, if I was asking the question, what is the y-intercept, what would my answer look like? Nope. It'd be a point, and what would that point look like? 0, some number. Yep. So the y-intercept is always going to look like 0, some number. Follow-up question to that: how many y-intercepts can we have? 1? Can I have 2? No, can't have 2. So only 1?
Yeah.
What? I can have 0. So none or 1, right? Okay? Because if my vertical asymptote is x equals 0, then I can't have a y-intercept. Okay? So this is a none or 1 case. 4 steps in to our 7-step process. Okay? Step number 4. Is this the color that you wanted before? Okay. Step number 4. Find the x-intercepts. Okay? If there are any. How do I find the x-intercepts? So it's where my function equals 0, right? Okay. So where does my function equal 0? When it crosses the x-axis, right? Okay, what type of functions are we dealing with in this case or in this unit? We're dealing with fractions, right? Okay, so let's expand that. So if it's where my function is equal to 0 and my function is a fraction, where are fractions equal to 0? When the numerator is equal to 0. So I don't even need to set my whole function equal to 0. That part I don't care about. I can just set my numerator equal to 0. So it's just the top. So to find the vertical asymptotes, I set the bottom equal to 0. To find the x-intercepts, I set the top equal to 0. Okay? Now, what are those going to be then? No? Are they going to be lines? Are they going to be numbers? They're going to be points, right? What are those points going to look like? Hashtag comma 0. Okay. Now, how many x-intercepts can I have? Can I have none? I can have none. Can I have 1? Can I have 2? Can I have 3? 4? 5? So I can have 0, 1, or multiple ones, right? Ooh, I don't like how I spelled multiple already. Okay, so none, 1, or multiple. And actually, okay, you get it from the degree of the numerator. So the degree of the numerator tells you how many x-intercepts you're going to have. Okay? All right? Then we go on to step number 5. And step number 5 is find the whole if there is one. Now that we're going to save for Friday. So on your sheet, skip some space for step 5. Okay? Leave some space for step 5 because we'll fill in that on Friday and how we find holes. Okay?
A lot of space?
Just a little bit. Yeah. Okay? And then our last step is we find any more points that we need to graph it. Okay? So that might be 1 more point you need. It might be 5 more points that you need. That's a comfort for you to figure out how many more points you need. Okay? With me? All right, let's put it to work now in our packet. So now that sheet, that blank, well now I can't even say it's a blank sheet anymore, but this sheet that you just made, okay, that should be out next to whatever it is you're doing the rest of the chapter so that you get it memorized because you're going to go through those steps every single problem from now until next week Wednesday when we take the test on this. Okay? So when we're doing notes, it should be right next to your notes. If you're doing the homework tonight, the green homework tonight, it should be right next to the green homework tonight then. Okay? Because you're going to go through all of those steps every single time. Okay? So, let me restart. Oops, I don't want to do this, I want to do that. Whoa, tap the brakes. Now I got to go back and I got to do this. Ay, caramba. I had covered up this, and I had covered up this, and I don't even need to go down below that. Oh well, I'll do it anyways, because then it won't be on the notes. hit the wrong button. Okay. So, step number 1 is factor, or actually step 0 is factor. The only thing that I can factor is I can factor a 2 out of the top. Now again, the factoring step won't necessarily come into play today or Thursday, but it will come into play starting on Friday. Okay? So we're going to be wanting to get into that factoring thing. Okay? So we got it factored. Okay? Step 2, or the rest of step 0 then, is I need to find the domain of this function. It's all real numbers, but what? X cannot equal -2. Because if I have x equals -2, then I'm dividing by 0. Can't happen. Okay? For you original Ghostbusters fans, dogs and cats living together, mass hysteria. Okay? So, what does that mean in terms of vertical asymptotes? -2 is a number. X equals -2 is a vertical asymptote. Okay? So how does that then go onto my graph? Just as a line? A vertical dashed line. Okay? Now, I was noticing in the earlier class that when I was walking around and I was seeing people put their vertical asymptotes on, they kind of just lightly put it on there. Don't be afraid to make it bold and beautiful and big. Okay? Make it so that you can see it. Okay? Because you know that you can't cross that line. That is a wall, an impenetrable wall that you cannot cross over. Okay? So that you need to be able to see it. Because if your function crosses it, we got issues. Because then you're saying that your function exists at -2. And we've just said, not in our watch. Okay? Then, we said, what is the horizontal asymptote? We said earlier that this was y equals 2. Because I've got a degree of 1 on the top, I've got a degree of 1 on the bottom. So the coefficient on top is 2, coefficient on the bottom is 1. 2 divided by 1 is 2, y equals 2. How does that go onto my graph? Horizontal dashed line. Again, big, bold, so that you can see it. Okay? You want to be able to see that stuff. Okay? Next, it says, find our y-intercept. Whoa. Wow. That's impressive, I'm not going to lie to you. Just transferred my chicken scratch into type. Okay? So my y-intercept, how do I find my y-intercept? Put in 0 for x. So that's going to be 2 times 0 minus 4 all over 0 plus 2. 2 times 0 is? 0 minus 4 is? -4. 0 plus 2 is? 2. -4 divided by +2. -2. So my y-intercept is the point 0, comma, -2. Next, we find the x-intercept. How do I find the x-intercept? Look at your cheat sheet. Numerator equal to 0. So 2x minus 4 equals 0. How am I going to solve that? Add 4 to both sides. 2x equals 4. Divide by 2, x equals 2. So what's my x-intercept? 2, 0. Any other possible x-intercepts? No. Okay. Should only be 1 because the degree of the numerator was 1. So I should only have 1. Okay. So my function will start down here and it will come up and it'll go like this on that side. Because I have to go through the x-intercept and I have to go through the y-intercept. And I can't cross over the blue. With me? Okay. So now we have to come up with what my function is doing over on this other side. So I make myself a T-chart. This is that step 6, find additional key points to complete my graph. So I'm going to try, since this was a gap of 2, I'm going to try negative 4, and then let's go negative 10. Okay? So if I put negative 4 back into my function, 2 times negative 4 is negative 8. Negative 8 minus 4 is negative 12. Whoa, what the heck is going on here? Okay. Negative 4 plus 2 is negative 2. So negative 12 divided by negative 2 is 6. 1, 2, 3, 4, 5, 6. So I go through that point right there. Negative 10 times 2 is negative 20. Minus 4 is negative 24. Actually, hold on. I don't think I'd even go out 10. So let's go out, because I think we only go out to 8 on this graph. Right? 2, 4, 6, 8. Yep, I only go out to negative 8. So negative 8 times 2 is negative 16. Minus 4 is negative 20. Over negative 8 plus 2 is negative 6. Negative 20 divided by negative 6 is roughly about a little bit more than a 3, right? So 3 1/3. 1, 2, 3 1/3, so right in there. Do you need any more points to figure out where your function is going? And there's your function. Okay? Now, from that, I can say, well, as x approaches positive infinity, my function approaches 2 from below. As x approaches negative infinity, my function approaches 2 from above. As x approaches negative 2 from the left, my function goes to positive infinity. And as x approaches 2 from the right, negative 2 from the right, my function goes to negative infinity. Okay? Hold on. Double homework tonight. Okay? First homework is due sometime by Thursday. What I want you to do is I want you to, on your own, graph this function. I'm going to put it at the end of, actually I'll put it as a separate video on how to do it. Okay? So I'll put it on It's Learning Tonight so you can compare your answers. Okay? Second homework is due on Friday, and it's this green sheet that you can grab on your way out the door. Okay? Handle? There you go. Have a good day.